Now the part B of question answer. Here we know a uniform electric field exists between the two charge plate as shown in figure. Means these are two charge plate, one with positive, one with another negative. So field is from positive to negative, as electric field is always from positive to negative. Positive charge is always at high potential and negative charge is always at low potential. So what should be the work done in moving a charge along a rectangular path A, B, C, D, A? This is what? Electrostatic field. This is electrostatic field. This is again conservative one. For the conservative field or conservative force, work done along a closed path is always 0 irrespective of the shape. This closed path may be circular, rectangular, square, triangular, or any closed path, any irregular closed shape. But if the path is closed, in that case work done is always 0 because initial and final point is same. So final is VA, initial is also VA, so potential difference is 0, so work done is also 0. Next question is, what should be the work done if a charge plus Q is taken from point A to B on the circumference drawn with another charge plus charge at center? We know if plus charge is there, due to this plus charge at every point on this circumference potential is same. At point A potential is VA, that is V. At point B potential VB, that is also equals to V. So work done is equals to W is equals to Q VB minus VA. As both have the same value, so potential difference is 0, so work done is also 0. So it's quite clear that work done on moving the circumference of equipotential surface is always 0. Next question. Charge plus Q is placed at point O. Now, is the potential difference VA minus VB is positive, negative, or 0 if Q is positive and Q is negative? Due to this charge Q, potential at A is simply V is equals to K time Q by, let this distance be RA. And at point B, this potential will be K time Q RB. It's quite obvious that RA is less than RB, so VA is greater than VB. If Q is positive, then VA minus VB will be positive. But if Q is negative, then this is minus, 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 plus. Higher term has a negative sign, so the answer will be negative. So if Q is positive, then this term is also positive. If Q is negative, this term is negative. Next is, why is potential inside a hollow spherical charge conductor constant and has the same value on its surface? As we know, E is equals to minus dV by dr, or we can say dV is equals to E dot dr. If we take integration on both sides, we get it's equals to E dot dr or dl. If potential difference is 0, if field is 0, then potential difference is going to be 0, then both the potential is same. So potential is same. So the potential is going to be same inside the conductor and on the surface. Next is, why do equipotential due to uniform electric field do not intersect? If they intersect, that means at same point we have two value of equipotential, which is not possible. So that's why they do not intersect. Next is, a hollow metal sphere of radius 5 cm charged to potential at the surface 10 volt. It's a conductor because it is a metal, so it's a conductor. What is the potential at the center of the sphere? As we know, inside the sphere and the surface of the sphere, potential is always same. If on the surface potential is 10 volt, so means inside everywhere potential, even at center, the potential is going to be again 10 volt. irrespective of the radius and other factors. This is again same. Work done in moving charge 500 microcoulomb between two points on equipotential surface. As surface is equipotential, so potential difference is 0. If potential difference is 0, then work done is also 0, because W is equals to VA minus VB. If this is 0, then complete term it's going to be 0, irrespective of the value of charge. Next question. The dimension of atom are of order angstrom. There must be a large electric field between the proton and electron. When they are in electrostatic field inside a conductor, it's 0. Why? If they are inside a conductor, then positive and negative charge neutralize each other. If they neutralize each other, it means electrostatic field inside the conductor is also 0. Next question. A metallic charged sphere is placed at the center of uncharged spherical shell. When they both are connected with wire, will any charge flow on the outer surface? Yes. Sphere has more potential than shell. If they are connected by wire, then potential, this is high potential, this is low potential. So charge start flowing from body at high potential to body at low potential, means charge start flowing from sphere to shell. Next is, does electric potential rise or fall along the electric line of force? Electric line of force are always from positive to negative direction. Positive is always at high potential, negative is always at low potential. So if charge is moving or something is moving from positive to negative or moving along electric force line, means they are moving from high to low, so potential is falling. Can electric potential be 0 while the electric field not 0? Yes, as we already had discussed the case of electric potential at equatorial plane due to the electric dipole. Means this is an electric dipole, positive, negative, center of dipole with length 2a. We already find this expression. This is a point on equatorial plane. What we observed, at this point potential is 0. At every point on this line or plane, potential is 0, but electric field is not 0. It's always opposite to the dipole moment. It's always opposite dipole moment, but potential is 0. So here E is not 0. On equatorial plane of dipole, E is not 0, but V is 0. Next, can electric field at a point be 0 while electric potential is not? Yes. Inside the surface of a conductor or equipotential surface, electric field is always 0, but potential is not 0. Next question. Consider two conducting sphere of radius r1 and r2 where r1 is greater than r2. If these both are same potential, the larger sphere has more charge than the smaller sphere. State whether the charge density of smaller sphere is more or less than, means we have to find, than the larger one. As we both are the same potential, means first potential is q 4 pi epsilon naught r1, second is this 4 pi epsilon naught get cancelled with each other, means we get this term. As we know, r1 is greater than r2, so therefore q1 is greater than q2. If sigma 1 is charge per unit area is but 4 pi r square. So what we observe, if we take the ratio of these two terms, sigma 1 and sigma 2, we get sigma 2 by sigma 1 is r2 by r1. If we have substituted value of q2 by q1, that is r2 by r1 into r1 square by r. As r1 is greater than r2, so therefore sigma 2 is greater than sigma 1. So we can say density of small sphere is more than density of large one. Next, do electron travel to region of higher potential or lower potential? We know electric field is always from positive to negative. Electron always go opposite to the electric field, means from negative to positive. This is the flow of electron. So they are moving from low potential to high potential. So they always move toward high potential and move away from low potential. If we say about proton, then they will move toward low potential.